So we will now be focusing on quadrilaterals, but first we have to know the definition of what a polygon is. So take a look at all of these figures down here. The ones that say yes inside of them are polygons. So here, 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 this is not a polygon. Not a polygon, no, no, yes, yes, no, and no. What do we notice about the ones that say no? Why are they not polygons? They're not closed figures. Like for this one, for instance, there's an opening here. All the sides are not connected. Here we have intersecting lines. That makes it not a polygon. And also any curved sides or lines also make it not a polygon. So here's some basic rules to be a polygon. The shape must be closed, meaning there's no openings in the sides. It must have straight line sides, no intersecting sides, and also, again, we repeated this here, so that's all we really have for polygons. Let's take a look at some examples now of how we get to specifically a quadrilateral. So a quadrilateral is any four-sided polygon. The four angles in a quadrilateral add to 360. So the reason being is that any quadrilateral is made up of two triangles. And we know that triangles, the interior angles add up to 180. So if we look at a parallelogram, for instance, it's made up of two triangles. So all of these angles add to 360 as well as these. Therefore, all the angles in a parallelogram add to 360. And that goes for any four-sided figure. So let's practice here. To solve this, we would add up the three angles and then subtract it from 360. So for number one, we would add 110, 93, and 90 degrees. That would give us 293 degrees. We would then subtract that from 360. And we would get our remaining angle is 67 degrees. For number two, angle E, we would do the same thing. We would add 152. 130, and 22, which would give us 304. We would then subtract that from 360. Finally, we would get that this angle here is 56 degrees. So let's look at some specific quadrilaterals. A parallelogram, which we have talked about. A parallelogram has opposite sides that are congruent and also parallel. So if QR, this side here, was 6 inches, then the other side was 6 inches. If this was 12, this would be 12. Opposite sides are congruent. They are also parallel, meaning if they continued on forever, they would never cross each other. So opposite sides parallel, opposite sides congruent. Now let's focus on the angles of a parallelogram. The opposite angles of a parallelogram are also congruent. So for example here, if angle P is 62 degrees, then the opposite angle R is also 62 degrees. Consecutive angles in a parallelogram. So that's angles that are next to each other. So if this angle here is 81 degrees, angle P, any angle next to it will be supplementary. And remember, supplementary means that they add to 180. So 81 plus 99 gives you 180 degrees. So this angle would be 99. This would be 99. And then remember, opposite angles are congruent. So this would be 81 degrees. And then lastly, another fact about a parallelogram is that their diagonals bisect each other. So here, if QS is 24 inches, so from here to here, then that would split in half at the middle. So this would be 12 and this would be 12. Now, the diagonals are not congruent. So do not get confused on the fact and think this whole diagonal here is congruent to this diagonal here. Those will be different measurements. But when they meet, they do bisect each other.